where we're going to begin with triangles is with the simplest kind of triangle that we can work with, okay? So even though trigonometry deals with all kinds of triangles, which means it deals with circles and any other kind of repeating thing, like acoustics or radiation, all that kind of thing, we're going to start simple and then build from there, okay? So, identifying sides of right-angled triangles, let's draw one. Let's just draw a right-angled triangle like so. Okay, so you got a triangle that looks something like that. Now we want to be able to talk about triangles and use a common language, right? The idea is a bit like, tailors, they write down those four numbers, okay? But they know those four numbers refer to particular things. They refer to this circumference and that length and so on, okay? And then if that tailor gave the numbers to another tailor, they would know what they're talking about because they've got this common language. So we're going to establish some common language for triangles, okay? Now, just by convention, if we just label this a little bit, we usually call the corners of a triangle by capital letters. And we also usually call the sides of the triangle by lowercase letters. We tend to name them like this. See how this one's capital A in this corner? The one that's opposite, we name it little a. Okay, so this one's capital B, so the one opposite that is little b. And the one opposite capital C will be little c. Okay, which is why when you first learnt Pythagoras' theorem, which is not what we're doing today, but clearly it's related, we usually write it as a squared plus b squared equals c squared, right? So you can see the c is the long one over there. Okay. All right, now, just on that Pythagoras theorem idea, this c, right, it's special. It gets a special name, right? We call it the hypotenuse. Good. So, this is the hypotenuse over here, right? So we name it that side. Now we want some names for these other two sides. And the way we're going to do it is, we want to think about, this is about triangle measurement, okay? In particular, the big core idea here is that if you know the sides, it tells you something about the angles and vice versa. Just like if I know something about my neck circumference, you automatically know something about my height and my shoe size, blah, 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 okay? So here's what we're going to do. We've sort of run out of letters. We've got lowercase ones here, we've got capital ones here. To refer to a particular angle, I'm going to go to a different alphabet. So I'm going to call this angle over here in the corner, I'm going to call it theta. Okay, so it's this angle here, theta. That's how you spell it, if you're curious. I said I'm going to another alphabet. This is the Greek alphabet, okay? You're going to see a whole bunch of Greek letters. Yes. Theta, you'd appreciate that. Theta is written like a zero, right? And then it's kind of got like a tail in the middle. Kind of like a cube, but the tail's in the wrong spot, okay? That's theta. You're going to meet a whole bunch of other ones. Like I'll introduce them as we go, okay? But that's theta. Right, now, we've got the hypotenuse labeled over here, okay? Now, I want you to put yourself in the position of this angle over here. Like, as if you're standing there. Like, suppose theta is, suppose it's you, okay? Now, from this vantage point, I can name these other two sides. For instance, see this one? Lowercase b, right? See how it's next to where you are, right? I know the hypotenuse is next to you as well, but we've already got a name for that. Okay, you hold on. You know, but not everyone else does, right? So, since it's next to you, it's adjacent to you. That's another word for it. I'm going to call this one down here the adjacent side. Adjacent. Okay, that just means, next to you. Okay? And the same way, remember, you're standing over here, you're theta, okay? When you look across to lowercase a, right? This side is facing you, it's opposite you. Okay, so we'll call this one the opposite side. Okay, or if you like, the facing side. So this kind is your neighbor, and this one's over the other side. Okay, now here's the important thing, and it'll help if you draw yourself another triangle exactly the same just next to it. Okay, here's the same triangle, still got A and B and C, still got little a, little b, and little c. Okay, now, this time I'm going to put another angle in, right? Instead of theta over there, okay, I'm going to have a look at this opposite angle up here. Okay, so I'm going to call this one alpha. So I've got theta. Let's build our alphabet, shall we? Alpha.
That's how I write
Okay.
my
Okay, now that I'm over here, right, the perspective is shifted a little bit, right? Now you're standing up here, okay? C, lowercase c, is still the hypotenuse. It's always the hypotenuse. The one that's opposite the right angle is always the hypotenuse. So we never need to worry about what he's called, okay? But this side over here, we called it the opposite before, right? But it's not opposite anymore, yeah?
Adjacent.
It's the adjacent side to you, to your angle, right? So now this one is adjacent. They've swapped around. Can you see that? And this guy down here, he's swapped too. He's the opposite now. Okay? So here's this important idea that the hypotenuse always stays put. But these two, they're kind of relative to where you are, right? Just like when you say, oh, who's my neighbor? It's like, well, it depends where you're sitting, right? You've all got different neighbors. Just like each angle has a different one, okay?